Hello everyone, my name is Golden Yao. I'm a program manager from SQL Server High Availability team. Today I'm going to introduce you the new technology AlwaysOn from SQL Server 2012 and how you're going to leverage this one to design your high availability and a disaster recovery plan. I'm going to talk about the design pattern, architectures, and the best practices using AlwaysOn. When you're designing your production deployment plan, there's a common question you should ask yourself. What is your disaster recovery plan? We've been asking the same questions to our customers, and some of them just came up with help. So it's not going to be enough. For this session, there's some prerequisites you probably need to understand. We need you to have the basic knowledge of AlwaysOn failover cluster instances and AlwaysOn availability groups, how to set them up, what's the concept, how you're going to leverage them. And also there's some terminologies like high availability, disaster recovery, and the RTO, RPO. RTO is the recovery time objective, which means how soon you want to get your service back online should a disaster happen. RPO, recovery point objective, which means how much data loss you can afford during a disaster. In SQL 2012, we provide you with 3 different solutions for HA and the DR. The first one is multi-site failover cluster instance. This is not really a new feature. Failover cluster instance is supported since SQL 2005. So in 2012, we actually improved it, and now you can create a failover cluster instance across multi-site. So this solution requires you have shared storage and also hardware level replication between your storage. This is an instance level high availability solution and also instance level disaster recovery. It doesn't require database to be in full recovery model. For the other two, if you look at the deck, we actually require the database to be in full recovery model. So the second one is availability group. So this one is a new feature in SQL 2012. We heard people are saying shared storage is too expensive. So in this solution, you do not need a shared storage. You can use all the direct attached storages. And this solution is also a set of databases failover together. So it's a database level high availability and the database level disaster recovery. Another benefit from this solution is you can now leverage all your replicas to be active secondaries. You can use them for reporting service or use them to do the backup jobs. So there's no more idle hardwares in your whole plan. As I just mentioned, it requires the database to be in full recovery model. You need to do a full backup for your database and before you can add it into the availability group. The third solution is a hybrid of number 1 and number 2. You combine them together, you provide an instance level high availability for your local data center, and you provide a database level high availability and a disaster recovery for your DR side. Some other benefits, it's the same as the number 2 solution. You can leverage your active secondaries, and also it requires database to be in full recovery model. Now let's talk about the first solution, multi-site failover cluster instance. So in this solution, you create a SQL Server failover cluster instance on top of Windows Server failover cluster across multi-sites. So this solution provides you with local HA as well as the disaster recovery from the instance level. Your client is connecting to the virtual network name, which is associated with the SQL Server failover cluster instance. And during the failover, the client should retry to connect the same name as the failover going. And also instance will restart, which will require the database to go through a recovery process. For the DR side, it requires your storage has the hardware-based replication technology. This technology technology is provided and supported by the third party. So do check with your hardware vendor, make sure they can support this. I'm going to talk more about how we're going to support multi-subnet in this solution. So here is an illustration how the multi-site failover cluster instances work during a disaster recovery. So here inside A, you can see we have a 2-node SQL Server failover cluster instance. They were using one shared storage here. On the side B, which is the DR side, we also have 2-node failover cluster instance sharing the same send storage. And you have a hardware level storage replication from side A to side B. And right now, the active node is this one running SQL Server failover cluster instance. The local node is passive, and for the local HA, the remote node also passive for the disaster recovery. Now let's say there's a disaster happen. What's going on is in the side B, the storage is going to detect the replication state. There's no more replication from side A coming through. So what this storage going to do is it will enable the read-write for this storage. And the WSFC, which is the Windows Server failover cluster, will mount these physical disk resources, and then it brings the SQL Server instance come to the side B and start to write the transactions into this shared storage. Let's say after a few hours, side A comes online, the disaster is gone. You repair everything in the side A. These two other nodes will now become a remote data node, so which means they're passive because the primary is running here. And then the storage replication will be re-established from side B to side A. So the storage you see here is a shared storage. We heard our customers, based on their investigation or research, they see their 40% I/O with the shared storage is on the temp DB. So right now in SQL 2012, we also did an enhancement. We allowed the local temp DB for your FCI instance. It will significantly reduce the space you use for your shared storage and also the I/O load. For the network part, before 2012, we do not have any native support. So you have to create a strange VLAN to simulate you are creating a failover cluster instance within one single subnet. So this solution is hard to maintain and also has some security concern. Now in SQL Server 2012, to create a multi-site failover cluster instance is natively supported. We add IP address from both subnets and use OR relationship between them, which means as long as there's one IP online, the whole failover cluster instance is online and it can serve the requests. We also do register all providers IP during the setup. So both IPs will be registered into the DNS server. So during the failover, if your client needs to connect to the new IP, they don't have to resolve the DNS again. So that will improve the application failover time. So here are some screenshots when you set up this multi-site failover cluster instance. On the left side is what you can see from SQL. When you add a failover cluster node, it will ask you to add both IPs from each subnet. It will also tell you we will use the OR relationship for the IP. The right side is if you go to Cluster Manager in Windows Server failover clustering, you will see the listener and see two IPs under the listener, they are combined with OR relation. Here's some challenges and considerations. The first one is about the storage validation. When you do the storage, so you need to skip the storage validation check and select I do not require support from Microsoft for this cluster. So there's agreement that a multi-site FCI solution does not require passing the storage validation test. The reason for that is because you add shared storage on both subnets. One shared storage inside A is not visible to the other two nodes inside B. So the storage validation is going to fail. So it's okay to skip that during the setup. Also, you need to consider appropriate core model. If you run the cluster testing when you set up the Windows Server clustering, the validation suggests you use node and disk majority because it detects there's a shared storage. This should be ignored, as I just mentioned, because you will have more another shared storage from another side. So a correct way is to use node majority or node and a file share majority. We'll talk more about the core model in this session. And also, I mentioned when we create the virtual network name, which is actually the listener, we set register all IP, providers IP equals to 1. So this will make sure we register both IPs in DNS. So here brings another problem, because for the legacy client, if you resolve the DNS and come back with two IPs, it will randomly try one IP first, waiting for the timeout, and try the second IP. So that's why we also shipped a new client driver. You now can add another keyword, multi-subnet failover equals to true in your connection string. So if you have this keyword in your new client driver, it will automatically start to connect both IPs in parallel. Whichever returns first, it will just connect. For the legacy client, you need to configure the client timeout value appropriately. Reduce the timeout value so it can reconnect the second IP. That's unfortunately we still don't have a perfect solution for the legacy client. Now I'm going to talk about the second solution, availability group for HA and DR. So before in SQL Server 2005, 2008, and 2008 R2, many customers using database mirroring for local high availability and combine it with log shipping for a disaster recovery solution. We have many customers are using it. Examples like our internal customer MSIT, SAP, and external customers like BWin and Servicio. So in this solution, you can see that you have the primary data center with your principal and a mirror. You have another witness server, so which can allow you have automatic failover between your principal and the mirror. The log shipping is going to your DR side. It will be delayed applied to your DR side secondaries. It's a very common solution before. Now with SQL Server 2012, the first thing we changed is now you require Windows Server Failover Cluster. This is Windows technology underneath SQL Server Availability Group. You set up the Windows Server Failover Cluster between your primary side and your DR side. You add all the nodes into the one cluster. Then you create a single availability group across all three nodes with the databases you want to fill over together. So now you can have your synchronous data movement from the primary to your local secondary, and you can also have another data movement, either synchronous or asynchronous, from the primary to your DR secondary. This is the physical replication technology, same as database mirroring, there's no delay applied. So as soon as the secondary gets the transaction, the primary now can truncate these transactions. You probably still need a file share witness if you want to have automatic failover. Depends on how you set up your quorum, how many nodes you have in your data centers. So I will talk more about the witness and the quorum in the next session. Another thing I want to mention is there's up to 4 secondaries you can have. So in this picture we have 2 secondaries. You can have other 2 more, so which give you additional resilience, and also you can scale your read workloads. Some considerations in this solution. As I just mentioned, all SQL servers, they are in the same Windows failover cluster. And also this means you also need to put them in the same domain, because right now we can only set up the cluster within the same domain. And all the databases you want to add into availability group must in full recovery model. You need to do the full backup before you can add them into the availability group. And the third one is very important. The unit of failover for both local HA as well as the DR is at the age level, which means it's the database level. A set of databases failover together. It's not at instance level, which is in solution 1. You can there's 2 other things you can think about. First thing is to use contain database for containing all the logging information during the failover. Contain database is also a new feature in SQL 2012. So if you use contain database after the failover, you don't have to create like login, all these kind of information for your DR side. If you have any jobs or like agent jobs, other regular scheduled things, a simple customization probably is needed after the failover. Another thing you probably can do is when you write these jobs, you always do a check to see if the current replica is the primary. You can retrieve this value from DMV or stop proc. So if the job detects this is the primary, then it runs. If it's not, it stops. If you do that, then you can deploy the same agent jobs on your both primary data center and your DR data center instance. So should a failover happen, you don't need to do any customization to make the DR side work. I already mentioned there's no delay to apply on the secondary, so they will truncate the transaction logs as soon as it's applied on the secondary. If you remove log shipping, it also means the regular log backup job is removed, which means you need to establish your log backup jobs for yourself. We also have some new tools like monitoring, alerting. We designed a new AlwaysOn dashboard in SQL Server 2012. You can see all the replica status, and also we retrieved the DMV to show them in the dashboard. You can detect like how far behind the secondary is, how much time it needs to restore the whole database, how much time it needs to be fully synchronized. We also have the integrated solution with System Center Operations Manager. You can also combine all your monitoring into System Center Operation Managers. Client connectivity. So you can connect to the AG listener with your read-write workload. Another thing I want to mention is if you are using a failover partner keyword in your connection string, it still work, but you need to configure all the secondary to do not allow the connections. So how the failover partner worked before is it connect to both instances together, and whichever returns first, it will connect. So that's what a failover partner does. So to still make this happen, you need to disallow your secondary replicas from connecting. So that's why you need to disable your readable secondaries. Make sure allowed all connection is disabled, and the allowed read-only intent this connection is also disabled. So this is about the failover partner. How about if I want to leverage my secondary to do the read-only workload? If that's the case, you have two ways. The first thing is you can connect to your secondary instance directly, but you need to allow this connection. So go to the availability group properties and make sure these secondary replicas, you set them as allowed connection. Or you can leverage another feature called read-only routing feature. So you can connect through the virtual network name, the edge listener actually, and put application intent equals to read-only in the connection string. So when the primary gets this request, it will redirect this to the first available readable secondary. So basically you offload your read workloads to your secondaries. I already mentioned multi-subnet failover keyword in solution 1. So this also applies to solution 2. If you use availability group listener and across multi-subnets, you want to use multi-subnet failover equals to true in your connection string if you're on the new client. For the old client, that's the same thing. Just configure the client connection timeout value to make it connect to the second available IP when it gets from the DNS. So here comes the quorum configuration. How are you going to configure your quorum in this solution? The first thing is you need to think about which node you want to give the vote. The suggestion from our side is you need to have one vote for the node, which is the primary data center, and also it participates in the automatic failover. All of these replicas should get one vote, and a 0 vote to all other nodes. There's no way you can configure the votes from SQL Server or any GUI. You have to configure this using a PowerShell or cluster.exe command line to assign or change the votes to every node. The second step is to consider your quorum model. We already mentioned there's node majority, node and file majority. So basically in this AG solution, usually use node majority if you have odd numbers of nodes. If you have an even number of nodes in the cluster, then you probably want to consider node and file share witness majority. So just to clarify, the file share witness doesn't need any SQL Server installed on that. You basically, it could be any server, just host a machine and host the file share, which is visible to all the other nodes in the cluster. Okay, so here is the diagram, how you're gonna configure the votes and the quorum in this solution. So let's assume in the primary data center we have two nodes, node 1 and node 2. In the DR side we have node 3, so there are 3 nodes in total. Now we give the primary node 1 vote, and we give secondary 1 vote because we want to have automatic failover between these two. We give the DR side node 0 vote because we don't have a plan to automatic failover on top of that, and it's a DR side. You do not want the DR side to impact your cluster healthy status if you lose your DR side. So that's why I gave a 0 vote. So now you have 2 votes in total in this cluster, but it's not enough because if you lose one node here, the whole cluster only have 1 vote, which is less than half. It's less than the half of the whole votes. So the cluster will still go down. The thing you need to do is you give file share witness 1 vote here. So the file share witness, as long as you add this file shared witness, it always has 1 vote. So now your whole cluster has 3 votes. So as long no matter this one goes down or this one goes down, you will have 2 other votes. So the whole cluster is still up, and automatic failover would happen. So now let's talk about the DR scenario. So DR scenario means there's a disaster happening. The primary side is down, and you need to fail over everything to the your DR side. Generally, it involves manual process. So if you go back to the previous slide, you can see if the whole primary side is down, the whole cluster will lose the quorum. So which means there's no quorum to have the DR side to come up automatically. So the thing you need to do is you need to use failover cluster manager or cluster.exe to force quorum in the secondary in the DR side to bring the whole Windows failover cluster up. So you can use -fq to, with the command line to bring this cluster online. So which means the cluster now is running in the forced quorum mode. The second thing you want to do is you want to use tsql on the secondary in the DR side, which is already up, to execute forced service allowed data loss on the availability group. So basically you're telling the availability group, I want to be running and I can afford the data loss. So now you have your availability group running in the DR side, and it's running in the forced quorum model. You want to use your PowerShell or cluster.exe to digest the node votes. So remember, we still have the DR side as 0 vote configured. So you need to change that. You assign 1 vote to the secondary in the DR side, and assign 0 vote to each node in the primary data center. So to make sure, in case the primary data center comes online, it won't impact the whole quorum model. So after that, your DR solution is completed, and all the services are running in the DR side. The third thing I'm going to talk about is the combination solution of number 1 and the number 2. You use failover cluster instance for your local HA, but you use availability group for your disaster recovery. So this is also a common solution before. We know Service U, Care Group, they kind of use this solution for some of their applications as well. You can see that in the primary side, you have a SQL failover cluster instance, 2 node, and they use a shared storage. In DR side, you have another SQL failover cluster instance, and they use a shared storage too. And you set up like database mirroring between these 2 SQL failover cluster instances. How's that going to change in SQL 2012? So in SQL 2012, the same thing, you need now to have the Windows Server failover cluster as the fundamental for them. Instead of the database mirroring, you use availability group between the primary and the secondary. So you create a database, and create the availability group, include these databases, and have the data movement from primary side to the secondary side. Here's some kind of considerations. The same thing, you need to have one single Windows Server failover cluster spread over the primary and the DR side. That's the same thing as solution 1. And also, another thing you want to consider is the DR failover unit is at the AG level, the database level. So you can, the same thing applies as solution 2. You can use contained database, you can use other objects, and for jobs, you can configure the customization things for the jobs. There's also some prerequisite Windows Service Pack and CAFE. The first thing you want to know is the asymmetric storage. So before, Windows Server cluster would not allow you to have this configuration because you have a storage there which is invisible to other nodes in the other DR side. So now you want to configure with this asymmetrical storage, you want to install the QFE for SQL Server 2008, and this is the QFE, and for SQL Server 2008 R2, you can install a Service Pack 1. To configure the node votes, you need to install this QFE to be able to run all the votes. And there's another QFE to patch the validation disk test. If you don't have this, the validation will be failed and you will not be officially supported. So here is some screenshots for the steps, how you create the Windows Server cluster instance with 2 nodes and configure asymmetric storage. You set up the cluster first, and you new cluster SQL Server cluster installation. Then you add a node, so that's when you finish your first site installation. Now you add the other 2 nodes from SQL Server instance 2 in the DR side. That's 0304, and it will detect there's already a instance running in this cluster, so you want to keep it online, so you don't want to have any data loss. Okay, so now comes up to the validation test. So this one actually will give you a warning if you installed the QFE I just mentioned in the previous slide. If not, it will be a error. So now you have the 2 sites with the 2 nodes. Each site has 2 node Server cluster instance. Now you're gonna create the disk. You can use Server Cluster Manager add disks from the DR side. The disks will form a shared storage for instance 2 on node 3 and node 4. The newly added disk will be in the available storage, but it will remain offline. That's because the available storage groups is owned by the node 1, and these disks are not visible or owned by the node 1. So one thing you need to do is you need to move these nodes from availability storage to the node 3, which actually can own these 2 storage. Another amazing thing is you can even assign the same driver letters for the DR instance. Now you can see here you have in this Windows Server cluster you have 2 SQL Server cluster instances, and each of them has a bunch of cluster disks here, and every disk is online. You also want to change the possible owners, so make sure all the resource is owned by the correct subnet owners. All the resources sitting in subnet 1 should only be owned by subnet 1 one's node. Subnet 2 resources can only be owned by subnet 2 nodes like 03 and 04. Now everything is done, then you can create a validated group between these 2 FCIs. So when you create, you can use asynchronous or synchronous data movement for these 2 instances. And also make sure you can only pick up manual failover. You will not be able to see automatic failover as you can see here in the screenshot. This one is I copied from standalone instances. So there's by design, when FCI is combined within AG, automatic failover will only happen within the FCI. So from the AG level, there's no automatic failover. There's only manual failover you can choose. Okay, now you set up the availability group between these two instances. So now you have the database level failover for your DR solution. The same thing for client connectivity. I already repeated that in the solution 2. So all the solution 2 for connectivity apply to the solution 3. So these are the timeout and this other stuff. Current model. Current now is still managed by Windows cluster. No matter how many instances you put into, or it's FCI or it's standalone. So 2 steps you want to think about when you choose your current model. So still, step 1 is to select which node you want to get about. Step 2 is to select the appropriate current model. So by default, all nodes get 1 vote. If you want to have the node majority and with the even number, it's already set up. But in this case, because you have 2 different FCIs in 2 different subnets, we assume you have even numbers of nodes. So that's why you need a node plus disk majority. You can configure the quorum for one side. They have 2 nodes and 1 disk, so you have 3 votes. So Windows, you need the QFE to allow you to configure 1 vote for some nodes and 0 vote for some other nodes. So that's the same QFE I mentioned in solution 2. Also, you can only use PowerShell or cluster.exe command to assign votes to the nodes. So here's the diagram for the votes and the quorum. You can see that you assign 1 vote for each node in the primary side and 0 vote for each node in the DR side. Quorum configuration. Use a file share or choose node and a file share majority. If the primary FCI is the odd number, then you can use node majority. Here comes asymmetric disk as a quorum resource. So prior to asymmetric disk capability, for disk to be a cluster resource, it was required to be visible for all the nodes. With asymmetric disk, now a cluster disk can be visible to a subset of nodes. So you can do this cluster.exe command as the quorum resource. So here's a picture to show you how to configure this. Now you have 1 vote here, 1 vote here from primary side, and you have a asymmetric disk only quorum from here. So you have 3 votes total. Whenever you fail over outside of the primary FCI, you need to re-evaluate the quorum configuration. The primary FCI is the automatic failover target, so it failover just between all the nodes in the FCI, and it's an instance level failover. When you failover to the secondary, you need to think about now you need to give 1 vote to each node in the secondary instance. All the nodes participant in the secondary instance. You need to change it back to 0 vote to each node in the original primary. Make sure it won't impact the quorum mode if they come online. Yeah, you can also configure a file share with this in the DR side if it's even number of the total nodes. Here's the DR scenario. Disaster happened, and you need to have the manual process to failover to bring the database service online in the secondary data center. That's the same thing as we mentioned in solution 2. You need to force the cloud service running in the forced quorum model, and you need to force the AG to start with allowed data loss. So after its command line, you need to adjust the votes in the quorum. So here is how, after the failover, how the quorum settings, votes, and the replication direction. Now you're from the DR side to the primary side. Here's a recap. That's the 3 solutions we discussed and walked you through in this session. With multi-site failover cluster instance, you have instance level HA and DR. You don't need a database to be full recovery, but you need a very expensive SanDisk and have a hardware level replication. The existing solution, a corresponding solution is using a multi-site FCI by strange VLAN to simulate you're in a single subnet. The second one is the availability group for HA and DR. You don't need a shared storage. We have a set of databases failover together for both HA and the DR. You can leverage active secondaries. It requires database to be in a full recovery model. A corresponding existing solution is database mirroring for local HA and log shipping for DR. The third one is the combination for both 1 and 2. It has instance level HA but a database level DR. Other benefits are the same from availability group. The corresponding existing solution is you have a failover cluster instance for local HA but use database mirroring for DR. Alright, so that's it. So this is all I want to talk to you about how we're going to design the disaster and HA solution by using AlwaysOn. Thank you very much.